Another video on L'Hopital's rule. This is a rule for helping us find limits. So there's actually 3 strands to these. Strand 1 and 2, we'll do that today in terms of level of difficulty and what's needed for it, and then we'll do strand 3 in another video. Okay, so if you look up right up here, this is pretty much what it is. So if you have a limit in the form of 0 over 0 or infinity over infinity, and you want to find the limit of a function, now it has to be written as a ratio, okay, as one function on top, one function on the bottom. Then it's the same thing as taking the derivative of the top and then the derivative of the bottom and then plugging it in from there. Okay, so for instance, we look at our first example right here in this corner. For limits, we always just want to plug in and see if it works. So if I plug in a 0, I'm actually going to get 0 over 0. And in this case, what we would do before is I would tell you, oh, let's do some algebra or some rewriting of some sort. And that's actually really not possible for this problem. There's really not anything that we can do except we have to now use L'Hopital's rule. So what we're going to do is we have to take the derivative of the top, the derivative of the bottom. This is not quotient rule. This is taking the derivative of 2 separate things. Okay, so don't get confused with that. And then plugging in the 0 to see if it works. If it doesn't work again, then you would just keep taking the derivative until eventually that we can. All right. So in order to use L'Hopital's rule, I call it LHOP, by the way. To use LHOP, we actually have to go through and show that this is going to be of the form 0 over 0, and we need to be very technical about it. So, like I said, I just did a quick mental plug-in. I will get 0 over 0, but you do actually have to go in and show that the top function is indeed equal to 0. You have to show that the bottom function is indeed equal to 0, and then that will enable us to use L'Hopital's rule. You do need to show this work. Without this work, you're not allowed to use L'Hopital's rule. Okay, this is like the preamble to it. Once you show this work, and it has to be exactly as written. I was talking to some colleagues, virtually talking to some colleagues, looking at some message boards from colleagues of mine, and there's an AP grader that says if there's an LHOP problem, they don't have this written, they don't get full credit. So this does need to be written out like this, okay? You can ease up a little bit on this, and I'll show you where you can ease up on it. But for right now, I just want to make sure I do it completely perfect for this one. So now, if I'm going to use LHOP, I'm going to just write LH, letting the grader know, hey, I'm using L'Hopital's rule. So we're going to have the limit as x approaches 0 of, well, derivative of e to the x is e to the x, minus 1 is 0, so that just goes away. Derivative of the bottom is 3x squared. Now if I plug in a 0, what do I get? I'm going to get a 1 over 0. So this is going to give me a 1 over 0. Now do not write down equals 1 over 0 because that's not my final answer. Since this is 1 over 0, I need to investigate this because this is either going to be infinity, negative infinity, or it does not exist. So if I investigate this a little bit further, I have to approach this from the right. So as we approach 0 from the right, I'm actually going to get a positive value because everything is positive. E to the x is always positive, 3x squared is always positive, so I'm going to get a positive value. 0 from the left, actually nothing is going to change because e to the x is always positive and the bottom is always positive. So since I'm getting a positive divided by a positive, that's going to give me an answer of infinity. Okay? So there you go. Next problem here is, well, let's just use by investigation. Just plug in a 0 real quick. I'm going to get 0 over 0. Perfect. I actually have to show this work, though. So the limit is x approaches 0 of 1 minus cosine of x is equal to 0. The limit as x approaches 0 of x squared is equal to 0. Okay, like I said, you can actually ease up on this. And what you could do, you don't necessarily need this limit notation in this exact problem. I just like you having it because you will need it in other problems, which we'll get down to. If you want to just plug in 1 minus cosine of 0 equals 0 and 0 squared equals 0, that's totally fine as well. I'll show you that in the red. So if instead you have this 1 minus cosine 0 equals 0 and then 0 squared equals 0, if you put those things, then you're actually totally fine. You're covered. You're good. The Reason I don't do that is because, well, you kind of see that in the next example where I can't use the red. Okay, so now I know this is 0 over 0. I'm going to L hop it. So it's going to give me the limit as x approaches 0. Derivative at the top is going to give me positive sign, it looks like, all over 2x. Okay. Now, if I plug in a 0, I get, I'm going to get 0 over 0 again. So that means I need to L hop it again. Now, if you actually look at this, this is one of our trig stuff that we should be familiar with. We actually know how to do this problem without having to do L hop, using our trig properties of limits. But I will show you, I'll keep going with L hop. That way I can show you that L hop's required a couple times sometimes. So the limit as x approaches 0 of sine of x is equal to 0. The limit x approaches 0 of 2x is equal to 0, which means I'm capable of L hopping it again, which is going to give me derivative of sine of x is cosine of x all over derivative of 2x is 2. Now, if I just do a straight plug-in, I'm going to get 1/2. And that is my answer. All right. Moving on. Okay, so this is a one-sided limit. That's not really going to change anything for me, except that I do have to use this blue writing over here in terms of showing that it's going to be 0 over 0. Because if I plug in a 0, well, maybe it's not 0 over 0. This one's actually going to be infinity over infinity. Quick reminders of what some of these graphs look like. So here's ln of x, and I'll show you cosecant of x real quick, because if you don't know what these graphs look like, then it's going to be really, really hard to tell that it actually is going to be infinity over infinity or some form of that. So ln of x looks like this, with an asymptote right there. So as you can see, the limit x approaches 0 from the right of ln of x, that's actually going to approach negative infinity. And for cosecant, that's just reciprocal of sine. So it's going to look like this. Okay, so it's actually going to approach infinity from the right. So limit x approaches 0 from the right of this cosecant equals infinity. And I'm able to do L hop now. I know it's negative infinity over positive infinity, but that actually doesn't change anything for what we need to do. So it is going to be an L hop. Now some people are like, oh, this answer will be -1. It's negative infinity over infinity. Well, not all infinities are created equal, so just be aware of that. So it's L hop it here. So I'm going to be left with the limit x approaches 0 from the right of 1 over x all over derivative of cosecant is going to be negative cosecant x cotangent x. All right, now what's going to end up happening if I plug in the 0 again, I'm actually going to get another infinity over infinity. And I'm going to keep running through this problem because every time I take the derivative, I'm going to keep getting 1 over x squared, 1 over x to the third. And that's not going to end up changing. And down here, I'm going to keep ending up with cosecants with a bunch of product rules, but cosecants. So here, I'm kind of stuck. I need to actually use some algebra. So my hand has been forced. I'm going to use a little bit of algebra here. So I'm going to rewrite my cosecant cotangent stuff. So I'm going to get 1 over x, which, by the way, I know I have a fraction and a fraction. That's going to change here very shortly. Cosecant is 1 over sine. Cotangent is cosine over sine. Since I have fractions on the bottom, I'm going to flip the second multiply. So I'm going to get limit as x approaches 0 from the right of 1 over x multiply, and we're going to flip times negative sine x over 1 times sine of x over cosine x. And now I'm pretty much set up for success now because I'm just going to redo a little bit of rearranging here. I'm going to get the limit as x approaches 0 from the right of negative sine x over x times sine of x over cosine of x. Sorry, I know I'm writing to that a little bit. That says sine of x over cosine x. Yeah, help at all. So what's going to happen here is when I do a direct plug-in, I'm going to end up with -1 times 0 because this is a property that equals 1. So negative in front, -1. If I plug it as 0, sine of 0 is 0 over cosine of 0, which is 1. So it's 0 over 1. So it's -1 times 0. So my final answer is a big ol' 0. So we did all that work just to find out that it was 0. Okay. All right. So for the rest of day 1, I'm actually just going to do these next 2 problems for day 1, and then leave the bottom for my day 2, because the bottom one can be a bit of a bear. All right, so still talking about the indeterminate forms. So if you ever get like a 0 times infinity, or like an infinity minus infinity, you can always rewrite it as a ratio so that we can use LHOP. So this just requires a rewrite to use LHOP. All right. So for example, if we look at this one right here, if I plug in a pi over 4, what is tangent of pi over 4? Did you say 1? Very good. If you didn't say 1, get better. 1 minus 1 is 0, and then this is going to be secant of actually pi over 2. You plug in the pi over 4, and that actually goes to infinity, because if you have the graph of secant, it goes to infinity. So this would actually give me some form of 0 times infinity for this first example. So what I want to do is do a rewrite so I'm able to LHOP it. Easiest thing to do here with trig is, if you don't have it in terms of sine and cosines, then start changing that a little bit. So this secant, I can change that into a sine. So this secant changes to 1 over sine of 2x, not sine, cosine. What am I thinking? 1 over cosine of that, 2x. Okay? So now since that's written like that, let's just make this into that one fraction. So 1 minus tangent x all over cosine 2x. And there you go. Now it's LHOPable. So let's go ahead and show that it is indeed 0 over 0. So this is going to give me 0 of cosine 2x, which would 2x, not pi, habits. So that would give me cosine of pi over 2. Cosine of pi over 2 is indeed 0. So I do need to LHOP it. So the top's going to give me negative secant squared. Oh boy. There we go. Negative secant squared. Bottom's going to give me negative. The inside is going to be 2 sine 2x. And do a quick investigation here. Yeah, I can actually plug this in and it'll be fine. So plug it in now. I'm going to get, by the way, this negative's going to cancel out, so I'm not going to worry about the negatives. So I'm going to get secant squared of pi over 4 all over 2 sine of 2 pi over 4 is pi over 2, which gives me a 2 on the bottom. Secant of pi over 4 is actually root 2, so it's going to be root 2 all squared. Root 2 squared is 2. 2 over 2 is 1. And there you go. All right, last problem on these notes here. Give us a little space. All right, so this is one where if you were to plug it in, you would get an infinity over infinity just by an investigation, because you get 0 from the right, so you get 1 over small numbers, which is infinity, minus 1 over small number, infinity. So we need to rewrite this. The easiest way to rewrite this is to, well, get common denominator. So I would multiply this right side by x over x, and then this left side by sine x over sine x. So I'm going to get the rewrite here will be sine of x minus x all over x sine x. And if you're just plugging a 0, 0, 0, 0. So by investigation, it's going to work. Let's go ahead and formally write this down for my LHOP. in. So now I can L-hop it. If you take the derivative of sine, you're going to get cosine. So it's going to be cosine of x minus 1 all over. This is product rule. So this is going to give me sine of x plus x cos x. By investigation right now, if I plug in a 0, I'm going to go ahead and get 0 over 0 again. So let's go ahead and show that. Now, if this is multiple choice, obviously you don't need to show all these steps here, these technical steps, but if this was a free response, then yes, you do need to show all of these steps. Okay. So now I can L-hop it again. It's going to leave me with derivative of cosine is negative sine of x all over. It's going to give me cosine of x plus product rule cosine of x minus x sine x. Because it's going to give you a negative sign on that second one. And actually, I'm capable of plugging in a 0 now because I'm going to get a 0 on top, but then I'm going to get a 2 on the bottom. So if I just plug in now, I'm going to get 0 over 2, which is equal to 0. And there you go. There's your L-hop. Make sure that you do show the technical steps. You don't show that on a free response, you cannot get full credit. So there's your L-hop.